Here you can visit the whole value chain on power semiconductors, from the materials to the chip, to the packaging, and finally to the solutions.
At the very beginning of the value chain from materials to systems, we do pioneering research on high quality crystals and substrates. That's of course silicon carbide, but also very promising ultra-wide-bandgap semiconductors like aluminum nitride. All this offers the perfect basis for high-performance devices, energy efficiency, climate protections, and the power electronics of the future.
We are active in the field of silicon carbide technologies, where we develop power devices, CMOS devices for high temperature applications and also sensing devices. Further, we are focusing on silicon carbide MOSFETs.
We are fabricating a different kind of electronic device in our clean room facility. So we are a very famous institute for CMOS technology on silicon carbide and other ultra-wide-bandgap materials.
I'm the fab manager for our prototyping services for our customers and project partners. We are offering process services which includes individual process steps, process sequence, or even full runs of power devices and sensor devices based on silicon and silicon carbide on 150 and 200 millimeter wafer sizes.
We are focusing on the one side on new technologies for packaging and die contact, as well as module attach, for example, ceramics embedding. On the other side, we have all possibilities to build up here power modules in a small number.
I have the pleasure to destroy the stuff Hubert's built. We do lifetime testing according AQG, like power cycling, H3TRB stuff, and go beyond like corrosion testing. We try to understand the failure modes, we understand the material properties and do FEM simulation to do lifetime modeling and condition monitoring digital twins.
Our focus is the development of power electronics for mobility applications. Here you see our latest developments for the electrification of aircraft, new electric motors for aircraft propulsion, very high power density DC-DC converters to connect fuel cells and batteries to the powertrain, and special galvanically isolated converters. Here you see a demonstrator of a fuel cell powered aircraft with distributed powertrain, where we developed special DC-DC converters and also drive inverters for the electric motors. Here you see a demonstrator of a multi-level GaN inverter for high-speed drives used as electric air compressors for aircraft applications. An upcoming topic is the EMI behavior of the new power electronic solutions. We've developed an active EMI filter, which is much smaller and more lightweight than conventional solutions.
The goal of my team is the characterization and application of novel semiconductors in high power applications like railways and ships. Here at the end of the value chain, we showcase a prototype of our 3 megawatt modular multi-level converter with a noise reduction of up to 70% compared to state-of-the-art solutions.
We are here from Evolonic, student research group at Fraunhofer IISB, with highly motivated students from the FAU.
Our focus is to develop a drone which is used for wildfire detection.
In the project Power Care, we develop intelligent algorithms that, well, take care of power electronic systems. We just take the motor currents that are measured in the inverter anyways, and our algorithms can detect whether there is a bearing fault or not. Without additional sensors, we are always able to detect the health status of power electronic systems.